So hello again to panel 7. Panel 7 is a panel which is on policies for a green recovery of the building sector. My name is Veit Bürger. I'm the panelist. I'm the panel leader today. I'm working for the Öko-Institute, which is one of the large independent environmental research institutes located in the southwestern corner of Germany in Freiburg. The panel is co-hosted by Jan Rosenow. Many of you might know him. Jan from the Regulatory Assistance Project. Again, today, unfortunately, he can't make it for family reasons. So he's very sorry about that. And he sends his warmest regards to all of you. But today, I will be your panel leader. In the recent 3 days, we already had very interesting presentations, very interesting discussions. So I'm quite excited. I'm really looking forward to the discussions and to the input today. So I'm really looking forward to what is expecting us today. Today we have a somewhat broader scope. We have 3 presentations. The first one is looking at PV installations on non-residential buildings. The second one, there we have a contribution that discusses how to extend today's often applied very narrow view of an isolated building to districts. And the third presentation is on multiple benefits associated to the refurbishment of the building stock. A technical issue, again, in the beginning, I think you are quite used to that now. If you have questions, please submit them in the question and answer section at the Woover app. I will collect them and then I will put them forward to the panelists. And we will start right away with the first presentation, which is provided by Katharina Reindl. Katharina is a researcher at the Lund University, and Katharina, I don't know, Katharina
is perfect.
Okay, is talking about PV installations, the role of property owners of non-residential buildings in energy transition. Katharina, you have the floor.
Hello and welcome everyone to our presentation, PV installation, the role of property owners of non-residential buildings for the energy transition. This is a research project funded by the Swedish Energy Agency and conducted by my colleague, Professor Janne Palm, and we are from the International Institute for Industrial Environmental Economics at Lund University, which you can also see in the background. So the aim with the project is to analyze perceived barriers and enablers of PV installation in Sweden by property owners of non-residential buildings, which was initially also the aim for this presentation. But we have now already an article published on these barriers and enablers in Sweden and also conducted an international literature review. The reference for the paper you can find on the slide, so please go ahead and read the paper if you're interested. Since we have already an article published on that, we thought we would, for this presentation, discuss a potential second paper or another analysis another day on our material. I want to first start with some background information. Solar energy is very important, or a very important technology to mitigate climate change. And if we want to achieve EU or national goals for renewable energy and for reduction of greenhouse gas emissions, the transition of the electricity system needs to increase rapidly, and PV can play an important role in that. And PV also play an important role and can contribute to decarbonize the housing sector. Why we studied non-residential buildings is because there's a lot of potential roof space with non-residential buildings. Here is a slide on PV capacity in Sweden. This is taken from the report by Lindahl et al., a national survey report of PV power applications in Sweden. If you're interested in more information on PV capacity installed in Sweden or policies, please go ahead and read the report. It's very extensive and informative. So in Sweden before 2006, there was mainly an off-grid market, a small but stable off-grid market with installations for holiday cottages, marine applications or caravans. And since 2007, the grid-connected distributed PV has increased quite a lot. And in 2019, the total installed PV capacity in Sweden was around 700 megawatts. And the Swedish Energy Agency says that now in 2020, it has actually gone just over 1 gigawatt. So PV is increasing quite a lot in Sweden, but in the total electricity production, PV in Sweden is about 0.3%. In the distributed market, self-consumption business model played an important role in Sweden. There are also capital subsidies, but there were actually never any feed-in tariffs in Sweden. If you look at installed grid-connected PV power, it is 46% residential systems, 46% commercial systems, and only 5% centralized PV parks, which is a relatively small number so far. But there's a lot of interest in that and predicted to grow quite a lot in the coming years. So the focus of an additional analysis, what could that be that we would like to discuss and present to you today? So what we have done is to map barriers and enablers, which is good to get an overview and an understanding. But in a way, it's a bit maybe reductionistic and it isolates some factors. So what we want to do here is have more a context and look at the investment decision more embedded in a context. As a methodological approach, we have done 25 semi-structured interviews with non-residential property owners from different buildings like hospitals, school, offices, warehouses, elderly care. So it was a quite broad variety. And the respondents were, for instance, CEOs, environmental or energy managers, electricity consultants. And we also had buildings with different sizes and ownership structures. So it was public and private housing companies. And we had 2,600 square meters to 2.1 million square meters, so quite a big range here too. So what we are asking ourselves now is how to best understand and analyze these companies, because we had a big variety of different companies in our sample. And this is just still an idea that is developing, so we're looking forward also to your input and questions and comments. So we have thought about some main ideas that would be to look at these companies with ideal types. That was done, for instance, if you're familiar in sociology with Max Weber, he has done a lot of analysis with on ideal types. There's also an interesting article by Högberg et al. From 2009, where they look at how companies reason and act regarding energy efficiency measures in housing renovations. But the question is, can you develop ideal types based on an investment decision on PVs? That's still something we're thinking about. We could also look at different adopters. There's the diffusion of innovation literature by Rogers. He has a broad variety of adopters, but the PV market in Sweden is not that developed that we could apply all these adopter types. Alva Palm and Jenny Palm separately both did an analysis on motives of PV adoption in Sweden in the residential sector. And there they both looked at earlier and later adopters and differences there. Then we could also maybe do a practice theory inspired approach to looking at PV installations. We have Patio et al. From 2014 who looked at renovation decision as a practice, and it's not maybe the practice of one individual household, but if you look at renovation decisions on an aggregated level, then you can maybe see a practice on an aggregated level, and we could do something similar. What we have done so far, what is still in development, is to look at different adoption types or adopters and when in time they have adopted PV. So we have in our interviewees have adopted PVs more than 10 years ago. And we can also see that they have installed much more PV systems than the others. And they can be described as optimistic champions. They're very positive, they see very few issues, and are very happy with their PV installations. Then we have adopters that adopted less than 10 years ago, roughly, and they have a bit less PV systems installed, and they can be described more as cautious optimists. They see a lot of potential, otherwise they wouldn't have installed it. They see profitability, but some of them, the more recent, the ones that adopted more recently, still evaluate and test their systems. And then we have non-adopters. There was one interviewee that was very knowledgeable, but clearly saw no profitability in PVs, and the others were not so knowledgeable and very skeptical towards PV. So we see clear differences in when a PV system was installed. We also looked at differences. Of course, this is a qualitative study, but we also looked a bit at differences between public and private and sizes or different building types. And the clearest differences we saw when in time PVs were installed. So then we looked a bit practice theory inspired. What did they say about engagement and meaning and goals, information, routine and habits, explicit rules and financial support and technology. But this is still in development and we're looking forward to your feedback. So if we look at engagement, meaning and different goals, we can see that people that adopted PVs 10 years ago had a very clear focus on environment and energy. It was very important for them, and they all had very concrete goals formulated also for their companies. Whereas people that adopted less than 10 years ago, environment and energy was also very important for them, but not all of them had concrete goals formulated. With the non-adopters, we have this one person that was very knowledgeable, and their company also had environmental and energy goals, but really decided to not go for PVs. The others didn't have environmental goals or energy goals or a big focus on these issues. Some of them just recently started with some CEO changes, but it's new for them. Profitability was seen varied. The ones that adopted earliest see it as profitable without a doubt. Payoff time of 12 to 13 years is regarded as good, whereas the non-adopters wanted to be at least less than 10 years. And the people that adopted less than 10 years ago see the profitability on the edge. It is profitable, but maybe not for more installations. It's still a bit unclear. So PV is an important part for basically all of them in their sustainability strategy and corporate image, PR value. So building on such interconnections seems to be fruitful. Then regarding information, there was not so much issues seen regarding information for people that adopted earlier on, but then it gets a bit varied how much information is out there and how good the information is. Also, if there's a lot of experience and routines and habits established and negotiated in an organization, that seems to determine whether PVs is installed. And if one PV system is installed, it increases the possibility to invest in more. It seems to be some kind of institutionalized decision making. It's easier to make the decision again. You have routines already. For the people that adopted already, in-house aggregated knowledge was seen as very important and good. They have a knowledge base within the company, and they also highlighted good relationships with suppliers and contractors, which was very good and important for them. Regarding explicit rules and financial support, the ones that adopted earlier see no issues with that or easy to navigate. There are some issues, but later adopters find it not so easy to navigate, and non-adopters, some didn't even know anything or didn't even know that there are subsidies actually. What could be problematic is that rules, support and taxes have varied over the years, which is difficult to keep up. It's maybe good to assess and streamline administrative processes and remove building permits to make it easier to install PVs. That was an issue for some. And changing the tax and value-added tax rules. There's this 255 kilowatt rule in tax rule in Sweden, which is counterproductive if you have more power installed than 255 kilowatt, you pay taxes, which then is also counterproductive for larger systems. This was changed just after we did the interviews. Now the line is 500 kilowatts. So we will see what that will change in the future. Selling electricity is also seen as too expensive by our interviews and slowing down PV installations. Regarding technology, our interviews that adopted a long time ago were very content with their installations. They see it as a mature technology. And the ones that adopted a bit later, most of them are content, but many are still evaluating and don't know yet if it's good or not. And then the non-adopters are very skeptical and see it as an immature technology, and they don't want to be the guinea pig for a new technology. What many saw is issues with roof construction of existing buildings. So it's maybe good to catch property owners before renovation or a new construction. And also if there are issues with the roof, to encourage different business models where the property owners do not own the solar cells themselves, but maybe own shares in a solar PV park. And also to support solution, virtual or physical, that help property owners to store solar. So overall, we can say to increase PV installations, there's no fits-all policy recommendation. There are different views and different needs that need to be taken into consideration. And several factors can be both a barrier and a driving force. So thank you for your attention, and please stay in touch and let us know if you have questions and comments, and we look forward to the discussion.
So thank you, Katharina. Thank you very much for this interesting input. There's already one question from our audience. It's more a technical question. Do PV plants owned by farmers classify as commercial or as private?
That's a good question. That's a really good question. We excluded that in our study. I guess you could discuss if that should be private or property owners, but we made the distinct decision to exclude that from the study here.
Okay.
But that's an interesting discussion. Okay. And it was also just an interesting story. It was one of the interviews, I just thought about that. He actually, there was one person that owns shares not in a PV park, but from a farmer who has quite big solar cells installed. So that was also a solution to increase the shares, but we didn't look at agriculture in this study.
There's another question you mentioned. You mentioned the case where not the building owner himself invests into the PV plant and operates the PV plant, but where you suggested to think about the development of different business models where the building owners could, for instance, rent out the roof to others, and they install and they invest and then operate. Did you also investigate into the barriers against these kind of models?
We asked we didn't really look at that model in itself in depth, but we asked if that was a model that would be seen as useful or not. And it was interesting. There were a few that saw it was quite useful to maybe have a different business model, especially also thinking of roof construction, because roof construction was a big barrier for people to install, especially existing buildings, and we need to work with existing buildings. We have so many existing buildings. So that would be an option, but many didn't even think about that as an option actually. And during the interview, it came up, yeah, maybe that would be a good solution actually to own shares in a PV park, or have a different solution like with the farmer. So we didn't look at the different business model as such, but if that would be a good option or not.
Okay. So I know from some countries, at least I know from some regions in Germany, they start to think about and even implement some kind of regulations, obligations for when it comes to this construction of new buildings or the renovation of the roofs of existing buildings, major renovations in particular, to oblige the building owners to use the roofs for PV installations. What do you think about this kind of approach?
That's an interesting approach. I guess that could be a way forward, maybe. but there are different tax rules also in Sweden that limit how much roof space could be used. Now that has been increased, as I mentioned, but I mean, there is so much roof space that we need to use in one way or another. And there was a really interesting presentation, if you have a chance to look at that, yesterday by Diana. In the afternoon, they did a calculation on roof potential, how much potential there is in roofs actually, versus maybe having PV parks. And PV parks, maybe you use land, that land could be used for other things. Maybe you have some issues with biodiversity, but there's so much potential in roof, and they started to create a model on the potential of roofs that are out there. So yeah, we should definitely work with them.
Okay. So for me, it was quite interesting to see really that you emphasize on the commercial sector and the commercial buildings, because we all know that often the commercial buildings have the large roofs.
Yeah.
But on the other hand, we know that producing electricity is not the core business of those who work and own the buildings, and
that was also an issue sometimes with the tenants, and how do you do that installing, and who pays for the electricity, and the contracts that you have with the tenants. That can be an issue with these commercial buildings.
Any idea to how to deal with this problem that you also mentioned in your abstract, the problem with the constraining factor with the roof statics?
Yeah, that's a really good question. That has been an issue for many, because the existing buildings often are not good enough, and then it's quite a large investment maybe to bump up the roof or make the roof stronger. So that's why we also brought up the idea maybe to have different solutions and have different business models, because maybe not all the roofs are suitable to install PV. So that was an issue also that the interviewers brought up a lot, that's constraining them.
Okay, so thank you for the moment.
Thank you.
We might come back to you and PV on commercial buildings in the final panel discussion. But now we have to move forward. We will go to the next presentation, to the next contribution, which is provided by Sophie Schnapp. Sophie is an independent environmental consultant, as far as I know, based in London. And Sophie is talking about enabling positive energy districts across Europe. Energy efficiency couples renewable energy.
Hello, everybody. My name is Sophie Schnapp. I'm an environmental consultant, currently based in London, but spend a lot of my work life and other life in Europe. We've just had the hottest day of the year here in London, so it almost feels as though we are in the south of France together, having a jolly and educational time. Thank you to Panel 7 and the eceee for having me. I'm pleased to be talking to you today about a project that was set out to link energy efficiency and renewable energy and understand how this works to upscale positive energy districts. So a little bit of background. We all know the extremity, the actions that we're taking in the next 10 years and what that will mean for 2050 as per the IPCC report, etc., etc. And we know that they're crucial to curbing emissions and transforming Europe into the first climate neutral continent by 2050. We've seen in recent years that the EU have actually been moving towards a more decentralized structure, and the energy landscape evolves. The importance of communities being key to decarbonizing Europe is recognized as being crucial. We see this in some of the European Commission directives and strategies and programs going forward towards 2050, particularly the Clean Energy for Europeans package that places communities and citizens at the heart of it for the decarbonization strategies. The strategy for energy system integration envisages the evolution of the energy landscape towards 2050 as policies promote change towards increased decentralization and distribution. The Energy Performance of Buildings Directive has a definition of what a nearly zero energy building should be, and that includes renewable sources that are produced on site or nearby, and a building that is of very low energy demand. And this definition actually could include district level concepts. And the Renewable Energy Directive also has a definition and requires for member states to put in place the policy framework to adopt renewable energy communities. So why a positive energy district? Well, we asked this question and we found that in the literature review and in interviews, there were many different reasons as to why we should really develop positive energy districts and what these mean. So a district level energy efficiency measures on individual buildings can lower the overall neighborhood energy demand. And when we look at district level technologies such as renewable energy systems, local energy networks, and energy storage, they can offer a very cost-effective solution. And then establishing a kind of performance guarantee in carbon savings and energy savings, which then improves investor confidence. Establishing a positive energy district involves consideration and identification of the diversity of the energy interplays in the building's different energy performances and production capabilities, opening up the possibility of sharing the neighborhood's energy needs, costs, and resources. A positive energy district can also provide scope for optimization, and more so than for a single building. And also building systems can be specifically designed and can have tailored load profiles to enable high use of carbon-free renewable sources. So this paper's aim is to consider the performance need of an energy district and investigate ways of setting positive district targets in relation to energy efficiency and renewable energy. The point and the purpose of the study is to actually suggest a methodology to help developers and policymakers in establishing cost optimum, minimum performance energy districts. We were hoping and looking to see if it was possible to adopt the EPBD's cost optimal calculation methodology. And this was found to be a useful tool and strategy to be employed, that can be employed by a range of stakeholders, communities, developers, and local and national policymakers. So we wanted to look at the performance aspects of a performance energy district and use this to guide local municipalities, urban planners, and again, policymakers to make a roadmap and to be used for both district and national level projects. The way that this project was undertaken was a three-layered approach, and it was founded on expert knowledge, essentially. And then there was a lot of scientific literature that helped to fill in the gaps and feed in the science that we needed to make the recommendations that we have. We looked at more than 50 peer-reviewed and different papers in scientific papers. We interviewed 20 plus experts as well from the field of energy efficiency, renewable energy, districts, policy, the private sector, to find out what their approach would be and how they saw positive energy districts going forward. And what this meant was that we could provide some policy implications and develop an 8-step to developing a positive or zero energy district target and strategy, and explore the possibility to have the positive energy district concept included in EU legislation, particularly with a focus on buildings. So here, we've seen, and literature shows us that there are so many different ways of defining a district, a green district, a positive energy district, a plus energy district, a zero carbon district, and they all are pretty similar, but they have different caveats, whether it's looking at focusing on carbon or whether it's focusing on the energy use or the boundaries. But essentially, they're all pointing towards the same goal, to make districts green and work together. This actually bit of research was done by a very good friend and colleague of mine, Jens Lausten, I think maybe even 10 years or 15 years ago. So this isn't a new concept. It's just that we haven't started to implement it enough yet, although the ball is now rolling. So to define a positive energy district, we looked at current policies in place, as well as different research and literature, and also looked at specific districts that are positive energy. And we took different parts away with us to develop a definition of a positive energy district, which is an area with defined borders that is based on open and voluntary participation, is autonomous and effectively controlled by its own citizens, whose primary purpose is to provide environmental, economic, or social community benefits. It has an overall energy balance of 0 or positive over a year. It has buildings with a very high energy performance, complying with applicable minimum energy performance requirements and local building codes. It has buildings with the nearly zero energy concept or very low energy demand linked to the Energy Performance of Buildings Directive, and the next two are also linked to the definition of a nearly zero energy building, but translated into a district. So it has a building demand covered to at least a very significant amount by renewable energy sources, and where the renewable sources are produced on site or nearby. I thought it would be nice to envisage what a positive energy district would look like, and this is again taken from our literature review, but it's essentially a place I'm sure we would all like to live, and hopefully we all will live in one day in the not too far future. But it would be clusters of buildings of varied typologies and energy profiles, powered by renewable energy farms and building integrated renewable energy systems. They would all be connected to a centralized or an aggregated storage facility, and would have smart distribution networks, and would also make provision for future technological advancement in electrical and energy equipment that could encompass some of the points I make below. We found that there are some advantages and some challenges to implementing a positive energy district, and the advantages are primarily linked to economic, technical, infrastructural, social or societal, and environmental. And then the challenges are often based on complexities of the design process, regulatory issues, and the difficulties of actually achieving a consensus amongst stakeholders. With regards to the practical implementation of a positive energy district, we found that the designers and stakeholders would have many questions to pose and answer, such as how can the performance requirements at district level be defined? How can an energy balance be managed so that district borders will be unambiguous and high performance buildings are not double counted? How can legislation support community-led business models? How will a district level measure be financed, and who owns this measure? So these are our 8 steps for a positive energy district target and strategy. And these were developed based on interviews and literature, as I aforementioned, and are primarily made for policymakers, but also we would like to see how these would be implemented and used by local authorities, actual communities themselves. Each of the 8 steps includes multiple actions. Cost optimality is always used as a starting point, but we'd need more effort to reach a positive target, and we would want private investors to get involved in that. The approach is and could be deemed as being complex because there's such a vast amount of different combinations of technologies and approaches that can be taken on a district level. We also found that the data for the calculations are likely to exist, but are probably quite scattered, so would need a good amount of collection. So this methodology sets out the steps to enable the development of a cost optimal positive district, and enables the least costly route to meet positive energy targets. It's also in line with the EU Green Deal and the Paris Agreement, and to make sure it's in line with them, we stress the importance of taking the following into account when developing a positive energy district. So we would fulfill the energy efficiency requirements of the local building code. We would optimize energy efficiency versus renewable energy. We would optimize the supply of the remaining demand by on-site renewable energy, and we would optimize the supplies through a separate grid system. I'll take you quickly through the 8 steps. So step 1 is the baseline study and should be undertaken of the building stock in the area. Step 2 is the mapping of building technologies, its typologies, ages and sizes, and there are various methods to do such thing. Step 3 is recognizing the energy efficiency measures that can be undertaken in the district. Step 4 is from these baseline and packages of measures that we have already found, the cost optimality calculations can be applied to the buildings to establish minimum performance values. Step 5 is calculating the baseline and post-intervention of energy levels and allowing for the district energy demand to be defined. Step 6 is the cost optimal calculations. As they provide the district energy demand, the developers are then able to understand and employ the appropriate systems for heating, cooling, and electricity. Step 7 is the cost optimal energy performance calculation that can be made for all potential renewable energy district energy system alternative measures to be undertaken. And step 8 is the district energy performance target and the renewable energy system performance target that are combined and maximized. Our conclusions are renewable energy must be included within the district's plans, but the energy efficiency first principle should really guide the district's target definition. The cost benefit calculation methodology can be used on a district scale by aggregating the individual buildings, and renewable energy are used to be included in the cost benefit calculation methodology at building and district levels. The cost optimality calculation methodology must take into account the life cycle costs and the life cycle carbon of the efficiency and renewable interventions to ensure the carbon footprint of the district is accounted for neutral. Equally, the multiple benefits of the district are to be included within the calculations so that they are accounted for and valued, and this will actually lower the cost of the performance of a positive energy district. We would like to pilot and test this in the real world, both on existing districts and in up and coming positive energy districts. And the need for data monitoring methodologies and common definitions that are currently scarce are needed. Thank you so much for listening. I'm Sophie Schnapp, and please do get in touch.
Thank you very much for your presentation. Now there you are. So thanks a lot for your very interesting presentation. And we already have a couple of questions from our audience. The first one is, Sophie, with revisions coming this year of the Buildings Directive, the Renewable Energy Directive, the Efficiency Directive, is the positive energy district concept far enough developed to be included in the revisions?
Whether it's far enough developed or not, it has to be included if we want to get to zero. We've got very, very fast deadlines approaching. And I think without including these, then we'll be really setting ourselves back. And again, with deadlines and, with deadlines for a report or whatever kind of deadline, if you put them in place, then we manage to make it. So I think the overall idea of a positive energy district is a district that produces more energy than takes up. So however we manage to do that, we have to get there. Does that make sense?
Yeah, the question would be if the Commission would call you now or in 20 minutes after the session and would ask you, Sophie, could you provide a well-developed concept for the inclusion in the directives? Would that be available until summer, for instance?
I think that's what the 8 steps are trying to say. Is this is a very it's complicated, but there is an approach that can be taken, looking at the baseline of a district and seeing how we can, through the technologies that already exist, get to positive energy. And the infrastructure, the technologies, et cetera, exists. It's just bringing them together and working together. as opposed to them being siloed and separate kind of either strategies or policies or whatever is leading the way through the technology advancements. We need to come together and bring them together.
Okay, that means it's more a procedural challenge to bring things together which are already there.
Exactly.
Is that my understanding? Okay. There's another question. Do the objectives of the PED include reducing the need or investment in energy network infrastructures?
So can you do the investments in, can you repeat the question, sorry?
Yeah, does the question is whether the objectives of the positive energy district approach include the reduction or the need for investments in energy network infrastructures, so in the distribution electricity grids, in high transmission grids, and gas.
I mean, I don't, the study didn't look into this, and it's not, I don't think it's my place to say, but I think if you're developing a positive energy district, the infrastructure to share energy has to be developed by the developer if it doesn't exist at present. So you would either them or the municipality, but it would have to be without the connections, the positive energy district couldn't exist. So someone has to take account for it, and I'm not sure who would be the right person to do that, but
yeah, but I think there are two sides of the coin. On the one hand side, you might need more infrastructure within the district when you talk about heating pipes, for instance, or maybe expanding the electricity distribution grid. On the other hand, you might have less needs for high transmission lines in order to really because you have more electricity, more energy production on ground within the district. So that might have a positive and a negative cost effect.
The interlinkages between the households and the different supply systems within the district, even though it's now decentralized, there will still be a need for the development of infrastructure or grids to get it from A to B within the district.
Okay. So another question from Lorenzo from Milano. You mentioned EPBD's cost-benefit calculation methodology. It is important to focus on buildings and borrowing. That method is okay, but don't you think the costs and benefits considered should also be environmental, health, and land disruption costs? These aspects are missing in the cost-optimal methodology. So the question is whether the cost-optimal methodology should be broadened to include all the other aspects. I think which more or less brings us to the next presentation.
I couldn't agree more. And actually, it's funny, Daniel and I are the co-authors of this report, but also a very brand new report on the multiple benefits of energy efficiency and how we can include multiple these multiple benefits, these health effects, these other effects within the cost optimality calculation. So we have a calculation for you that includes them, and we agree.
Okay. And the final question, development of positive energy districts has also an institutional side with many more stakeholders compared to the construction to single building. How do you include the necessary coordination between stakeholders into your 8-step approach?
I think it would almost, that's a very good question. It would almost come before it. The 8-step approach is once people are on board and the positive energy district is about to be undertaken, if you know what I mean. That's where to find out how, how the district can actually get to positive. But in advance of that, there is obviously a lot of stakeholder interaction, bringing the local residents on board, getting everybody in line. So I think it would almost come before the 8-step approach, and I think that's a place that needs a lot of work. And I think it needs maybe a one-stop shop for funding and financing mechanisms, and the private sector coming on board and saying we're ready to finance things like this. It needs the legislation in place that's, as again, where we've taken the definition is kind of partly from the Renewable Energy Directive that states what a renewable energy community should look like. But why should we not have a legislation in place within potentially the EPBD that says, well, we're asking you to develop nearly zero energy buildings, so why can't you make it a district approach? So we need legislation, we need financing, and we need really effective ways of getting the consumers and the citizens on board and excited about what their district can be and what they can be doing.
Okay, I think the huge challenge is how can you get them excited about that? But yeah, thanks for the moment. If additional questions pop up in the next minutes, I will put them forward in the final session. And now we continue with the final presentation in this slot this afternoon, which is provided by Daniele Paci. Daniele is working for the JRC at the European Commission, so the Joint Research Center there. And he's talking about untapping multiple benefits, hidden values in environmental and building policies. Daniele, you have the floor.
Thank you very much. Okay. Thanks for the invitation. I'm very glad to have the chance to present this paper, which is also linked to what to one question we already have from the panel. So why it's important to include wider benefits in the cost-benefit calculations for energy efficiency interventions and policies. So my presentation today is about the hidden multiple benefits, the hidden values in environmental and building policies. I'm Daniele Paci from the European Commission, and I will try to move to the next slide. Okay. The hidden benefits of environmental policies are huge, and it is important to establish a value, a monetary value of all of them, because to make them recognizable, because they affect many different aspects of our life, going from health, the economy, environmental impacts, and these multiple benefits are not currently included in the economic calculation, either at private or at societal level. So it's very important also for private investors to have this calculated, not only for member states and policymakers to take decisions. The paper we submitted and we are presenting today is part of a larger project we JRC study, which I'm glad that Sophie participated and contributed most to this. It's a study that aimed at providing guidance to policy and decision makers in developing a methodology for including multiple benefits in the assessment of building renovation. So one first limitation I would highlight from the very beginning: we are looking specifically at building renovations. We are not looking at any energy efficiency intervention, but the general principles of including multiple benefits or hidden values may be extended to other energy efficiency intervention, not only building renovation, of course. But we are looking on in this specific study on buildings. The study included the information on the identified benefits, taken from the literature and from interviews with experts, a methodology for an improved consideration of wider benefits, in particular in the calculation of cost optimal minimum energy performance requirement under the EPBD, and a draft toolkit to calculate and quantify the monetary values of this impact, both from a policy and investor standpoint. As I said, there is a huge hidden part of benefits in energy efficiency in buildings. What we account today is mostly the energy savings, but there are many more benefits from energy efficiency intervention, including building quality, the value of the property, air quality in terms of outdoor and the CO2 emissions, economic growth, including the employment effect, increased innovation and competitiveness, health and well-being, comfort, increased productivity for office building, for example, and on the ground, even more hidden, it's a general concept that the improved the energy efficiency in buildings can lead to a more resilient, fair, and inclusive society. For instance, just to quote there are some studies now that that says that people that lives in a refurbished house have experience and improve in their social life, for example. So this is also why the renovation of building, energy efficiency renovation of building, is almost always included. Now we are seeing the recovery and resilience plans submitted by the member states for the recovery after the COVID pandemics, and in almost all the recovery plans, energy efficiency building is one key measure, and it's very important that to build a more resilient society. There are in the literature very wide and different taxonomies of wider benefits. Also, the labels changes from study to study. We just focus on we look at micro multiple benefits. We made a list here depending on the building quality, the economic, and the user well-being from individual perspectives. So building physics, aesthetics of the building, safety also is part of the building quality that can be improved through energy efficiency renovation, but also thermal comfort. If we look at it from the point of view of the user, indoor air quality, reduction of noise, pride, prestige, reputation. So these are all micro multiple benefits from a micro perspective. From a macro perspective, there are environmental benefits like air pollution reduction, the impact on greenhouse gas emissions, energy savings, of course, but also on the economic side, lowering energy prices, the effects of employment, so increase of employment, the creation of jobs is a very important effect. The effect on the GDP, reduction in the public budget, in the sense that the public spending decreases, but also on societal level. There are food poverty impact, increase in the productivity, increase in the health and well-being at societal level, which means reduce mortality and morbidity. So there are, and we listed only a few, so the list could be much longer and articulated. I will not go into the details of this. It's just to give you an idea on the methodology we follow to search the literature. Of course, a literature which is constantly growing. So this report is already at least 1 year old when we published. So the study was conducted at least 2 years ago. So still some references could be updated. So there could be also new projects, and we are sure that there is a lot of research going on in this field. But this is how we categorize the multiple benefits, the relative indicators, the description, and we try to extract from the relevant literature a range in the monetary value for the EU. So then we will, I will not go into the details, because then I will summarize it in the conclusions. And for the details, again, so you can refer to the JRC report, which is published and is available online. So here we list again the employment effect, the GDP, the public budget, energy security, health and well-being, mortality, morbidity, poverty alleviation, improved productivity. So, and from each of these impact or co-benefits, we search in the literature the most relevant and significant monetary range to try to give a first overview of the order of magnitude for the value we are talking about. Then we ask ourselves a question: how to include? This is more or less similar to the question that was raised before. So could we include multiple benefits in EU legislation? So the answer is the same that Sophie already provided before. So even if it's difficult, this is the correct way forward. And we try to express it also in formal terms. This is also here, I will not go into the technical details, but I will be available also after this session if you need more details or explanations. So this is a societal formula for the global cost concept, taken from the CEN standards and the guidelines for the minimum energy performance requirement, where the global cost is defined as the sum of the initial investment plus the sum of all the annual costs for the different components for a discount rate, of course, depending on the timing of the investment and the lifespan of the investment. Basically, if we consider the cost optimality calculation improved with the inclusion of multiple benefits, of course, with the exception of the cost of GA of the greenhouse gas emission, which was already accounted for in the previous one. The new elements highlighted in red in the slide are the savings related to the environmental impact. So we broadly group the multiple benefits in environmental impact, economic impact, and social impact. In this case, we subtract the savings from the cost, which is basically a negative cost. It's a benefit from the general formula. And to give a visual idea of this, there are the COPS optimality curves that plot the different points that relates global cost of the energy efficiency intervention and the primary energy savings on the horizontal axis. We'll see that including multiple benefits or societal benefits and environmental benefits basically lower the COPS optimal curve and push it push it downward. It is important to recognize also that it's not only this is just for illustrative purposes. This is not referred to any specific project, because of course also the shape of the curves depends on which multiple benefits it's added, the different conditions in different member states, in different contexts. So this is just for illustrative purposes, but the idea is that the curve would shift downward. This is more or less the same, but here is also evident that the cost optimal point tend to shift toward the zero global cost line. It means also that if we have a sufficient high lifespan of the investment and we correctly account for all different multiple benefits, it might be that for a relevant part of the cost optimal curve, this curve gives as a result a negative global cost. It means that the benefits overweight the cost of the energy efficiency renovation. This is of course also an example. So in this case, the cost optimal point, the minimum point of the curve, gives the same primary energy level, but of course the reference curve, which is the one without the inclusion of the multiple benefits, gives a reference for the investment cost. And so the difference between the multiple benefits and the reference curve can be seen both in the vertical axis, in the global cost, and in the horizontal axis in conjunction with the two different minimums. I'm moving to the conclusions. The conclusions are based on a deep literature review. Of course, doing, as I said, a literature review on multiple benefits, it's looking at a moving target, actually, because every month there are new evidence and new studies and papers published on the topic. So it's really a growing field of study, and this is very good, but it's very difficult to be updated. So we take a first step to try to monetize as much as possible the cost related to building renovation. And the range we found is that for energy savings, we are talking about 175 billion euros in 2020. The reduction of air pollution is evaluated in 2020 also in the range of 12 billion euros. GDP growth, for example, is plus 2.3% per year. Also, the improvement in terms of innovation and competitiveness are evaluated in the order of magnitude of 50 billion euros. These are for all Europe. And also the increased household disposable income, for example, it's very huge. It's more than 1,000 euro per year per family. So all this is, of course, there are not definitive number, but is just to give an idea of the magnitude we are talking about. And with these values, of course, with all the limitations and the caveats we have to say, it's important to see how this can really make a change in the balance between the costs and the benefits of the energy efficiency renovation. In terms of future challenges and limitation of these studies, we have to highlight that a comprehensive, robust methodology for including multiple benefits in the cost optimality calculation is possible, but of course requires additional research and data. And the interviewees suggested that the European Commission should develop a toolkit, online templates, basically, possibly based on our research, to enable member state to calculate the multiple benefits and requesting data points from each member state and calculating the multiple benefit using one of the proposed methodology for each different benefit, because of course for each of the benefits there is a different approach and methodology to evaluate the impact and to monetize them, of course. In our study, some also important co-benefits are missing. For example, we do not include the distinction between indoor and outdoor air pollution. We did not include construction and demolition, waste reduction benefits in terms of the circularity of the production process in the construction industry. We did not include the effect of lower energy prices resulting from the energy efficiency improvement. The subsidies avoided, the improvement in the building that lead also to improve accessibility for persons with disability, removal of dangerous substances, improved safety also for seismic risk, climate adaptation and resilience, just to name a few. So we concentrate on a number, quite a relevant number of multiple benefits. Of course, there are some others that are not included in our list. And also our report does not look specifically into the private perspective benefits, so the value of the assets, the effect of decreased bill payments, and so forth. Additional suggestion we have collected to overcome the current limitation, to address the challenges, is to develop a set of co-benefits to be calculated per building type, not just as a whole. So to go to be more specific on the building types, develop a list of possible EU data sources that each member state can use as a baseline data for cost calculation for each multiple benefits. Together with this, I would quote also a list of possible modeling software and companies that can undertake the modeling exercises of calculating the benefits for each country. Of course, more detailed information on how to gather and calculate the total cost for each multiple benefits, and a set of case studies to monetize each multiple benefits and to see how the different methodologies work in practice. I stop here. Thank you very much for your attention, and looking forward to your comments and questions. Thank you.
Thank you, Daniele. Thank you very much for this very interesting insight in the multiple benefits. I love this picture with the iceberg. And of course, I was aware of the fact that we need to talk about multiple benefits, but I was really surprised about the tremendous amounts of monetary gains which are linked to that. And so we already have a couple of questions to your presentation. There's one which is talking about the link of your work to the multiple benefit project. I just read it. I see a real synergy between the work you are doing with the nearly wrapped up multiple benefit project. Do you consider the M-benefit method and tools in the context of your work?
Well, actually, not because this is a recent project that is already concluded. It's just finished, as far as I understand. So, so this was not included in our literature review and in the review of our project. So, but we have other important project like the Combi project. We have studies from Cambridge Economics. So we have but not the most recent one. But we are so the idea is to include also the most recent development in follow-ups of this study.
Okay. Then there's another, I think, rather important question. So the values and the assessments of multiple benefits can be quite controversial, especially if monetization is needed to integrate these benefits in cost optimal or cost benefit analysis. Do your approach address this issue?
Well, yes, partly. So the issue is that we need a robust methodology. So I think that the most controversial issues in this relates to the difficulties. It's a methodological difficulties to translate the non-monetary benefits to assign a value to them. And of course, it's for example, we saw it also when we try to calculate the impact of climate change in terms of health. The health impact is one good example. How can you assign a value, a monetary value to a life or to decrease in morbidity? So it's I agree it's controversial, but at the same time, I think this should not be something that prevent us to try to find the most accurate and methodological robust way to do it, because it's important, because otherwise we end up having a sort of impasse. We cannot since we cannot measure this, or since we do not have the same units of measure, we cannot include them. So I think we have to make all the possible efforts to make this transparent, first of all, and robust methodology. So this is the direction we try to take. This is a very first step, but I think it's a way to go, because otherwise we cannot integrate really this wider band. We cannot make them emerge from from the sea level.
Okay. In another question which came up, you made this distinction between the micro multi-benefits and the macro multi-benefits. And from my understanding, the micro multi-benefits are benefits which really where the homeowner, where the occupants really have a direct benefit. Also there are these kind of benefits to the occupants. Often these kind of benefits are not taken into account when a decision is taken, for instance, whether to refurbish a building or not. So do you have any idea how can investors, how can private homeowners be encouraged to include or to broaden their decisions towards these multiple benefit approaches?
Yes, I think that one big first step is raising awareness. So I think the information campaign and also the fact that not only the individual building owners, but also the financial providers, financial institutions, banks, and are more and more trying to quantify these benefits and trying to being aware. I think it's a way to encourage also the private owner to take into account these, because of course, if not in most of the cases, the building renovation requires financial support from financial institutions, so a loans or a grant. And if the loan provider also is also able to calculate and to include in their calculation the multiple benefits, I think that this is also helps a lot in the decision at the home on the homeowner level. But I think the first step for all citizens is to raise awareness, to make this information available, simple, understandable, and not to make energy efficiency just like reducing your energy bill as the main message. So if you are renovating your house, you are really contributing to make your life better in a wider sense. So not only your life, but the life for your community and your society.
Okay. There, in particular, Lorenzo had a lot of comments in the Woover app with regard to the indicators in the cost optimality calculations. I think that are rather specific questions and comments, and maybe we can shift this discussion then to the end, or you do a bilateral discussion on that. I would like all of you, please, to now to switch on the camera on again, because I would like to start with a very brief final discussion. And I would like to start with a question which I already discussed with, or an issue which I already discussed with Sophie a bit. So the question of integrating these approaches into policy. So we already discussed about the question, how, to which extent could the buildings directive or the efficiency directive or the renewable energy directive adapted or extended in order to include these concepts. And I have the feeling that this policy approach would be one option, really, to include it. So to for instance, to allow member states, for instance, to include in their cost optimality calculations, to do the cost optimality calculations not only on the isolated building, but maybe also on a larger district, or to include the multiple benefits in these kind of calculations. Daniele, you showed this nice illustration, which showed how the minimum goes down on the cost curve. But I have the feeling that the other option would be to encourage member state governments or to encourage local authorities to include all these concepts when they take a decision on investments. Do you have any idea about that? Do you have a strong opinion on that? So would you concentrate totally on this policy path, or would you at the same time try to develop concepts if the integration into the European policy approach would fail over the summer?
Yeah, well, I think first of all, it would be good to, that you, as I said before, the Renewable Energy Directive already has demands for a renewable energy community to be defined, and then it also stresses and states for member states to develop policies to implement renewable energy communities. So equally, the Energy Performance of Buildings Directive includes they don't include a definition, but it's something, it's in one of the annexes that says moving forward to nearly zero energy districts. There's some word of district in the Energy Performance of Buildings Directive anyway. So the Commission, there's something coming in from Annette Pearson. So the Commission are already aware of the need to kind of implement and include these, particularly based on their progressive and quite strong and bold targets for 2030. It's being seen by the Commission as one of the key drivers to decarbonising, and in literature, in the interviews I've done, and the general consensus is that we're not going to get to zero without decentralising these energy systems and giving power to citizens to actually make change. So if we can help with that through policy, then I think it would be a really progressive policy to implement that can also be used around the world as a policy that's at the forefront of change. And then where to put it, you could put it within a new article of the EPBD, and equally link that to the Renewable Energy Directive and the Electricity Directive that we're already talking about it. Why should these directives be siloed equally? They should be complementing and helping each other to get to this one fundamental goal of getting to a decarbonised Europe and a decarbonised world. So more interlinkages between the policies helping support citizens, municipalities and national governments, but that coming as an enabler from the Commission.
Daniele, do you have a view on that?
Yes, I also agree with Sophie. So I think that the role of the EU policies as enabler of these changes is crucial, and I think the more coordination between the different legislative acts and yes, a stronger focus on innovative concepts like one on the co-benefits and the districts and they are fundamental importance if we want to reach the ambition, the ambitious goals of decarbonization. So we have to accelerate on this. But of course, then it's also this must also be complemented by increased awareness from the bottom-up awareness of these challenges. So, and I think that all contribution from municipalities or from local communities, from individuals, it's has to be encouraged. Of course, starting from the architecture of the EU policies, but of course with all possible means, either legislative, but also in terms of private investor. For example, I'm also involved in the energy efficiency financial institution groups that discussed in the past about multiple benefits, for example, and it's also very active at the moment discussing how to include multiple benefits in the for financial actors, and I think they are also a very important player to involve in the if we want to achieve a decarbonized society. So all actors are important. This is but of course, first big mover is I think it's European Commission. So.
Okay. But what could also be what could be done to really to increase the attention to these multiple benefits? When we talk to homeowners, to investors, to architects, it's either about kilowatt hours or about euros. So that are the most important units. And when you talk about indoor climate, improvement of indoor climate, and these kind of soft improvements, which you try to translate into Europe, so into also monetary improvements, I think that's one of the main challenges, really, to get these additional benefits into our thinking and into our decision making. And
it's not just about the decision making, because the decision making needs to include the multiple benefits, because that will help society, but it is also getting that into the mindset of human beings and the people that own the houses and the people that take the transport, and it's them understanding how crucial and how grave and great these multiple benefits are for them, so that there's a two-way coming together. There's citizens coming from the bottom up with policies coming from top down, and then the approach works. And we always talk about how to make this capacity building and how to really get people engaged and on board. And there are many tools that exist in the world, and this is a very siloed and different approach, but I've started working with a charity who are looking at how to include environmental objectives within the political policies, with cultural policies, and getting artists and musicians, etc., involved, engaged, and helping us to make change, because it's a key that the energy efficiency sector, the renewable energy sector, haven't used yet, but it can reach the masses. So it's using inspirational and exciting concepts that would actually allow us to see the difference that can be made from this top-down approach.
Okay. Katharina, did you ever think about, because I think there's also a link between at least the district approach and the non-commercial buildings, because they are within a district a huge potential for energy production, which is not only used in the building itself, but can be also used and can be very beneficial for the whole community there. Any discussions about that in Sweden, or any thinking about that?
Not so much for a district to use. It's usually used for the buildings, and there are some regulation issues to share electricity with other buildings. But that would be maybe good for the future, to actually have districts and maybe more a microgrid system in place, which is regulatory a bit problematic at the moment. But when I talked to the interviewees, they were all kind of open to that idea and would like to. And also, it's not possible to if you own two buildings, to share the electricity with the other building. But that's what many of them actually criticized and said they would want that. It's not very profitable to sell the electricity back to the grid, so they would like to use the electricity among their other buildings. So that would be a good approach. Also, if you think about how the electricity system should change in the future, and if we think more about decentralized systems, so definitely.
Or you make it more attractive really to sell the electricity to the grid, and or to the, not to the anonymous grid, but then to the district. And maybe there's an additional benefit on that. Okay, thank you very much to all of you. Thanks for the very interesting presentations, and thanks for your willingness to answer all the questions and for the discussion in the end. Thanks a lot. Thanks, of course, also to our audience. Thanks for all the questions you raised here in the Woover app and via the different channels. I need to make two additional announcements. The first one is that the panel 7 will have another session tomorrow at when is it? I think it's at 12. Yes, at 12:30 again, like today. So it's the final panel 7 session with, again, 3 very exciting presentations. But much more important is the final party. And I'm supposed to also announce the final party. So the 2021 Summer Study Party, of course, unfortunately also online, but which will be at 6 o'clock in the evening. You find the login data and everything in the Woover app. And the organizers seem to make a very special announcement. So no idea about that, but you should participate. So thanks a lot for participation, for joining us here in panel 7, and I hope to see you all tomorrow morning. Thanks a lot.
Thank you.
Bye.
Thank you.
Thank you.
Thank you. Bye.